Hello and welcome to another James and Chris science videos. Today we're going to be looking at basic electricity and what happens when electricity goes around a circuit. So, could you focus on this please? Right, okay, now, here is the most simple circuit I can do. We've got two components. The first component is a cell, not to be confused with battery. The word battery in English means many, so we talk about battery farming of chickens, we talk about a battery of guns. We don't necessarily refer to this as a battery, it's a misnomer in English. The reason we say this is we never use one on its own. We've always got more than one, so together it's a battery, so most devices need a battery of some kind. A car battery is lots of cells together. There's lots of examples. But if I showed you this, the most simple circuit I can, a cell, a light bulb, two wires. And I said to you, why does the light bulb come on? And most people look at that and say, well, that's easy, it's because electricity is going round. So if I then ask the question, well, what is that electricity going round? That becomes a harder question to answer, and one that we need to explore in more detail in order to find out the answer. So this is what we're going to do. We're going to look at the different parts of the circuit, and by the end of this little video, hopefully you'll have a much greater understanding for how this is working. First thing I'm going to start on is the wires, and inside the wires there is a particle that is involved with transferring electricity. The particle is something called an electron, and the electron is minuscule, it's tiny, and we know several things about them. So first thing I'm going to show you not what they look like, but some of the things that they can do. This is a Graaf Generator. This is very useful because it enables us to see what the electrons can do. It's all to do with static electricity, which we'll do in a video on its own. But inside here we've got a piece of rubber that rubs against a piece of metal, and as it does, it rubs off electrons, so I can look at them in a bit more detail. There's a motor inside. If I turn this on, it starts to spin. Right, we have lights, please. Thank you. The best way to show this is if I then put myself on here, and I put this here, hopefully you can see inside that kind of purple flash as it comes. Lights, please. So, what is that? Well, first things first, you're not actually seeing electrons. What you're actually seeing is the air as the electrons go past changing, particularly nitrogen. And as that happens, it causes the air to expand and contract, and it causes that kind of clap. It's what thunder is, but that's a very miniature form. You hear the air going out and then in. What we can see, though, is the electrons move, and you can see they can move from place to place, and we can hear them and see them. Not them, their effects. So, what else can we tell about electrons? Well, we know they move, we know they're tiny. They've also got a charge. The charge we can kind of show because charges are very good at attracting things. Can you see if we can focus on the water there? Thank you. So, let's charge myself up with electrons. And if I put myself here, you can see what happens to the water when I go close to it. See that? See that?
Big weird.
We liking that? Okay, so what does it do that? Well, it's to do with charges, and charges, very similar to magnets, is involving when things are the same or opposite where they attract or repel. So in terms of electrons attract water because they're negatively charged, and there's a part of water that is positively charged. So it causes it to come across together. So what do we know? Well, first things first, electricity is going to be electrons, and we know they are small, and we know they have got a negative charge. There's my electrons. We know that to start with. So what? Why does that create electricity? Well, to do with that, we need to look at the battery. And inside the battery, get this out, we have got two ends that you've got there clearly marked positive, and the other side marked negative. There's the positive, the negative one has rubbed out, but it's on there. So we've got a positive and a negative charge. So with what we know about charges, if I put an electron which has got a minus charge and I put it next to that one and I've got two negatives together, what happens? Well, the answer is they repel. They move apart. If I put an electron here, a negative and a positive, just like a magnet with a north and a south, they attract. So I get a movement of electrons towards the positive, and I get a movement of electrons away from the negative. So putting my battery into here, like so, putting this back in, I have got a positive end, so electrons are moving to the wire towards that end, and a negative end on this side, my electrons are moving away from that down this end. Well, how quickly are they moving? Well, the answer is to do with how positive and negative this is. Now, a good way of describing this is if I put some numbers on them. And if I said to you, well, let's just put an easy number. Positive 3, negative 3. So, those of you who are good at maths between you, what's the difference between positive 3 and negative 3? Well, the answer to that on the number scale is that is 6. And we would call that 6 volts. Volts being what the difference is between the positive and negative end of a power source. Sometimes called potential difference, in fact it should be called potential difference, which gives an idea that it's a difference between two numbers. Now, if I made my battery, that's a 6 volt battery, if I made my battery into a 12 volt battery, I've now got a reading of positive 6 and negative 6. So what's going to happen with that? Well, a positive 3 has got attraction for my electron, it's going to pull it towards it. A positive 6 is going to have a much bigger attraction and therefore is going to pull the electrons quicker. The quicker the electrons go, the faster they travel around, the more energy they've got. Now I want to at this point just to explain that the electrons themselves don't actually move very quickly. If I was going to measure the time taken from there to there, it would be taking about 6 hours to get from there to there. It does not travel very quickly. So how does the electricity get from there to there? Well, the answer to that is it comes in the form of a pulse. What happens is that electron moves, which pumps into that electron. Two negatives repel, so that electron will move, which will bump into that electron. That electron moves, and so it moves across there. So this original electron's only moved that far, but the pulse has moved all the way along the circuit. And it's this pulse that causes electricity to go through. Okay, let's consider current. So current is the amount of charge that is going to go past a point in 1 second. An amp is defined as 1 coulomb of charge, that's an amount of charge going past per second. Now to give you an idea of the numbers, 1 coulomb is roughly equal to about 6 quintillion electrons. Quintillion would be a number with 18 zeros. So a massive amount of charge has to go across to make 1 amp. That amp is a speed, an amount of electrons going past in that time. So 2 amps would be, at that point in the circuit, something like 12 quintillion electrons in 1 second. So the numbers are huge, but the actual charge carried by each electron is incredibly small, because they are incredibly small. Well, what does this mean? Well, each of those charges, as it goes through, is a form of movement, and a form of movement can be converted into different forms of energy, in this case into light. So each time electricity travels through that wire, it releases a small amount of energy and the light bulb comes on. So in summary, what we're talking about when we have a circuit is we have a positive and negative end, and we have our device here. There's my positive, there's my negative. This will be a positive end, positive 3, which will push electrons around the circuit. The electrons will pass through the device, passing electricity, and will go back to the battery. The voltage is the difference between those two numbers. The current is how fast the electrons are moving around. Thank you very much for watching.